apologise about that. So anyway, bit of a delay there. For those of you that are joining us for the first time, my name's Sant, and last week we'll just do a bit of a recap of what we did last week, and then we're going to have a look at aircraft performance, and then we're going to have a look at interpreting MET. So just to recap on last week, what we did was we had a look at our playground, basically what we can do for the various wind conditions that we have in Scotland. We also had a look at setting boundaries, and we had a look at our options as far as the terrain was concerned. And from that point of view, I was talking to Phil Dolan, who's a pilot that flies out of Scottish Gliding Union, and we were talking about the Aboyne database. Well, Phil has been updating the Aboyne database for the Portmoak area, which is basically up as far as Loch Tay, and he's updating it, and it will be issued shortly, and that will be done in a couple of weeks. And it would be nice if somebody up at Aboyne could have a go at updating theirs. But as I say, it should be updated quite soon, and it will be put on the SGU website. We also had a look at risk management. We looked at handling cloud and descending through cloud if we unfortunately have to do it. And there was a few questions that I missed, which I think need answering or deserve answering, which is what is my operating height band? Well, I like to operate ideally between 8 and 10,000 feet. Sometimes, as I said, minimum height you really want to be either in wave or looking for somewhere to land is 6,000 feet. I'll obviously go a bit lower these days, particularly over the Vale of Strathmore to the south of the Grampians. But at 8 to 10,000 feet, that's a good height band, because what you can do is you can look well ahead and look and see where the wave's going and plan flying the route that you want to do and where you're going to jump and all the rest of it. So that's the height band. Somebody also asked about winch or aero tow. Well, at Aboyne, it's all aero tow, and at Aboyne, they're very lucky in that they've got Morven Hill, where you just get dropped in the wave. Whereas at Portmoak, where particularly in westerlies, our wave works from westerly round to north. You can get the wave off the ridge, but depending on the day, it may take time to develop over Portmoak, and you have to spend time getting from the ridge into the wave, and that can take up to 2 hours. So really, what you want to do in all cases is take an aero tow and climb to, or get towed to 500 foot above cloud base, preferably in front of a cloud, and then that's usually a wave cloud, and off you go. So that basically answers that. Okay, so we'll go on to what we're doing today. We're going to have a look at aircraft performance. Now, this is not the UK. This is a picture that Phil gave to me from a New Zealand website, and that's New Zealand Wave. Absolutely stunning stuff. And what we're going to do is I've got the polar for the discus, and if I just bring up my pen or my marker, let me just have a look and see if I can get that. There it is. So here we've got the polar of the aircraft drive, no water balance. What we can see is that basically, as you can see, it's quite flat there, and it's about 1 in 43 at about 56 knots. All right, and as we can see, the polar goes down as we get faster. Now, if we have water in it, and this is full water, you can see that it's quite flat there. But if we look up here, there's your speed, so we can see that it's about 68 knots. All right. Now, if we look at our sink rate, we can see we're at about 120 feet per minute. Now, those are not ideal speeds to fly at, because when we're in wave, the wind's quite strong. And so what you want to do is fly reasonably fast. Now, what I do is I work on basically that if I can fly in a straight line in 3 knots of lift, I can keep going forever. And 3 knots, the average thermal in the UK is 3 to 4 knots. Well, if we use the average wave bar as 3 knots, anything in excess of 3 knots is a bonus. So you can see that if the aircraft is dry, my actual glide angle, or my glide angle at or my speed is 84 knots to give us 300-foot rate of descent. Whereas if I've got full water, which I can't obviously carry because I've got an engine, then it would be about 95 knots. Now, what that corresponds to is that 84 knots, I've got a glide angle of 1 in 28. Whereas at 95 knots, because the figures change, I've actually got a glide angle of 1 in 32. So I've got a glide angle 1 in 32 at 95 knots, and that's perfectly adequate for flying along wave. And as you can see, in kph, 95 knots is 176 kph. Now, people were asking what speed, they asked the question, how much height do you lose crossing a wave bar? Well, it depends on the wave, because if you've got 10 knots of lift, you're going to have 10 knots of sink directly in front of you. And the thing is that you obviously don't want to go across that bit. You go to the end of the wave bar and cross at the end of the wave bar if you have to jump. But basically, as far as the discus is concerned, you can see that once we start getting up to more than 113 knots, the polar really starts to drop away. So the maximum speed that I will cross our wave bar at is about 120 knots, unless it's completely dire. But 120 knots in the discus is about as fast as I really want to go. Now, we've been talking about the wind, and 60 knot wind is quite a fresh wind. Really, if you're flying in 70 knots of wind, you're really starting to get into issues. But 60 knot winds, if we're flying with the wind as a complete crosswind, what we end up with is if we're flying at 84 knots, we have a ground speed of 71 knots. I worked it out on my little whiz wheel, my little nav computer, the CRP5, and that works out at 131 kph. If I'm flying at 95 knots, I'm doing 150 kph. That's ground speed, taking into account a 60 knot wind at 90 degrees, which is the worst case you can have. Now, obviously, I always compare myself to John because he always sets the benchmark, and the Antares at 110 knots has a glide angle of 1 in 37, almost 1 in 38. If he has a ground speed of 95 knots, that works out 170 kph, 176 kph. And if he's got a still air speed of 95 knots, then his glide angle is 1 in 43. So you can see there's quite a bit of difference in performance. And that's basically it. I mean, I don't think you really need to know more from that point of view. We'll see how that obviously because of the way I've done this demonstration or this talk, if we can leave, I'll go through the questions at the end. Okay, so I've got this picture about the polar vortex because the polar vortex operates at a high level, or is at a high level. And basically, it's in the stratosphere. And what you've got is the polar vortex. People have heard about it because the Perlan project down in South America, what they're trying to use is the polar vortex to climb up to 100,000 feet. And the polar vortex is at high level, i.e. above the tropopause. And the tropopause at the pole, because you've got the troposphere where all the weather is. Stratosphere, you don't have any weather, or very rarely do you have weather in the stratosphere. But it's the tropopause at the pole is about 26,000 feet, whereas at the equator it's about 55,000 feet. And what tends to happen is you've got a relatively high pressure at altitude above 55,000 feet, and you've got a relatively low pressure at the poles. And this is particularly prevalent in the winter for the hemisphere that you're in. And so what tends to happen is you get a flow of wind going to the poles, and because of the Coriolis effect, you then end up with a big vortex. And the jet stream, which is quite important for wave, tends to follow the polar vortex. And the jet stream is around the tropopause, around 35 to 40,000 feet. And it can obviously be lower depending on where the tropopause is. But what it does is that with what we've got is this circular flow. But what's happened over the last few years is that you've got this cold air that's sitting over the pole, but because the Arctic is shrinking, normally what you have under perfect conditions is a low pressure over the North Pole. But what's been happening is, and when you've got it like that, you've got a very strong polar vortex and correspondingly a very strong jet stream. But because of heating and because the Arctic is reducing in size, what's happening is that you are ending up with, rather than one homogeneous low pressure, we're ending up with a series of 3 or 4 pressures. And that's actually what we got at the moment in the last week or so, because if you look at the jet stream, it's wandering all over the place at the moment. So, as I say, polar vortex extends from 8 to 11 kilometers, 50, 60 kilometers, and the jet stream is in the troposphere and basically follows the polar vortex. Now you're sitting there and thinking, why is this important? Well, the reason is that the jet stream acts like a lid, and because if you've got it waving, and what you want, we'll come on to it, is nice warm air, basically for really good wave. What you want is for a lid on it so that the wave amplitude continues, and so you get lots and lots of wave bars going downwind of the instigator. And so the jet stream acts as a cap and as a lid on what we have. Now, when we're talking about climates, right, this is a Köppen climate type, which has been around for about 150 years, but I find it very useful. And basically, the type of climate that we have in the UK is a temperate oceanic climate. And if we actually look at the climate that it says oceanic. But the interesting thing is if we look at Scotland and so on, you can see it's so polar oceanic, because we obviously get snow on the mountains and so on. So it's obviously colder up north, up here in Scotland. Now, what you do is, as I say, you've got the polar front, which is associated with the jet stream. And the UK is influenced by 4 air masses, basically. You've got polar oceanic, which is cold and wet, although it can, post-oceanic, if it's relatively dry, can produce some really nice thermals. And if we get a polar air mass coming in over the UK, it's usually a nice thermal air mass. And obviously that's from the sea. We're actually under the influence now of a polar continental air mass. We've got a high out to the east that's coming across Europe, cold air, it's coming across the North Sea, picking up moisture, and that's why we've got cloud down the east coast of the UK. So that's what we tend to get in the winter. In the summer, we tend to get the temperate oceanic, and if we get the Azores highs coming up, so on, then we get a nice warm air mass, and obviously we get a temperate continental if the air's coming up from the continent. So we're at a crossroads of all these weathers. Now, saying how the polar vortex is really weaving about. It's been doing this for the last few years. Remember the beast from the east that we had a couple of years ago? That was a polar continental air mass that came in. So if we go to the next slide, as I say, what you want is a nice warm air mass. And you've got the international standard atmosphere where the temperature is dropping at 1.98 degrees C for every 1,000 feet. The temperature at sea level is 15 degrees. And basic day goes up to minus 56, which is the tropical. And so if we had the ISO temperature at 500 hectopascals, which is 18,800 feet, what the temperature should be is minus 22. And basically, John and myself work on the assumption that if the temperature is below about minus 20, then that's the air mass is good for wave, and everything else being equal, then we've got good wave. Now, here's this is taken from Expert Weather Online, and as we can see, temperature is really warm down here, and we've got a depression up here where the temperature is obviously colder. Now, on this day, what you actually have is a front here. You have a front traveling across there, and so it wasn't actually a particularly good day. But if everything else was right, there would have been good that wave off the Welsh mountains there. And as I say, I can't remember the date of this one. It's just a slide that I use. But as I say, Expert Weather Online is a very good website, and I use it quite a bit. It's got a lot of features on it, which you can play around with. Now, I gave a talk last year on weather, and I used this particular chart because this is showing the jet stream, and this is taken from NetWeather, and it's showing the jet stream on the 21st of February last year, and this is taken at 9 o'clock local. And what we've got is we've got a ridge of high pressure here. You see what I mean? That this is the polar vortex. This is the jet stream. It's not the polar vortex. We've got a low pressure here. We've got a high pressure here. You see, you've got this air coming up from down south. I'll show you the synoptic in a minute. And what we've got here is a very steep omega curve. And so basically all around here, right, we're going to get wave if we're on the warm side of the polar front, right? Because the polar front is associated with the jet stream. And so there we go. We've got the wind speeds here, and you can see, and I think these are miles per hour, but coming down here, speeds 220 miles per hour. But that's very cold air there, because you can see where it's coming from the Arctic. But if we actually look at the synoptic chart for that, well, I've explained why the jet stream is important, as I say, because it acts like a lid. So I've already covered that to a certain extent. I've got a bit ahead of myself there. So just to carry on, if we look at that as a synoptic, there's the actual synoptic for 9 o'clock. And this is taken from the Met Office. And what we can see is that, yeah, the air is coming down from the Arctic. We've got a big low pressure there, a secondary low there, but it's being warmed up as it crosses the ocean, and it's coming up here. And as we can see by this, you can see the isobars are nice and straight, and what we've got is very warm, humid air. And the further up you go into the warm sector here, then the more clouds you get. But down here and around here, this is all pretty clear. And a really good thing, what's happening here is, because we were talking about the phone effect last week, what's happening here is that because the air on this side is colder than it is here, what we have, people talk about thermal lows when we're looking at really hot areas of the world. You get a thermal low, but what you're getting here is a phone, and you get a relatively low pressure in the lee of the mountains, and that's why the isobars kink. And so if you have an isobar kinking like that, sometimes it can be a trough, but in this case, what that is the effect of the phone effect. And as you can see, it's doing it down the Pennines as well. And as I say, the air is coming up, it's nice and warm. Now, as I say, on that day, Roy Wilson, what you had there was basically a southwesterly wind, did a 500 from Portmore, from Aboyne. And the temperature on the ground was 18 degrees. This is in February. The temperature was 18 degrees on the ground at Aboyne at the day. And he said it was very warm, but the winds were quite light, and say it wasn't a particularly good wave, but it was particularly warm. He said it was lovely, and you can read it up by looking at it on the BGA ladder. So that was the 21st of February last year, and this is we were talking about when I did 3 500 flights, 3 500-kilometer flights, or attempted to do 3 500-kilometer flights. And this is the synoptic that I took for that day, and it's at 6 o'clock. And what we've got here is the jet, but the jet's basically going like that. And this is classic northwesterly, where you've got a high pressure off to the southwest of our island. It's a wee bit high, in my opinion, but it wasn't bad. We had a nice northwesterly flow, and the air, as you can see, it's coming up from the tropical regions. So it's a lovely warm air mass. So that is really nice. And as I say, the jet would be going around like that. Now, we had this front, but early in the morning, what we also had, because that moved down, what we also had in the morning was a front going off that way, which eventually decayed and disappeared. And that created quite a bit of cloud. I'll be showing you some photographs later on. So you can get these charts off MetBrief up to 5 days in advance. And it's one of the charts that I always look at to get the general overview to see what we're going to do, or what potentially may happen in the next few days. Now, what I've done here is I've put up my bookmarks, and as you can see, I'm really well balanced. I've got my gliding bookmarks, and I've got my weather bookmarks, and these are all the ones that I use. And I've also got a load of webcams, which are very useful for on the day to see what's actually going on. And a really good one for Port Moat now is Perth Tower, which has just come back online, which is excellent. But what I tend to do is I tend to look at the Feshy webcam. I tend to look at the D-side webcam, just to see what's going on, because I'm going to demonstrate that in a minute. And I put that there because if it goes on video, you can see what sites that I use rather than me give you them all. But as you can see, I've got RASP, Top Meteo, and SkySight at the top. So what I'm going to concentrate mainly on tonight is RASP, because it's free. I'm going to talk a bit about SkySight. Top Meteo is not very good for wave, but I have it for thermal flying, and I have it for the satellite photograph because it's not bad at all from that point of view. But I'm mainly going to talk about RASP. So what you've got is 12-kilometer grids, and you can get that up to 7 days in advance. You've got 4-kilometer grids, which you get at in 3-day intervals, up to 3 days ahead, and then you get the 2-day ones, which tomorrow and the actual day. And I mainly look at the 700 millibar, which is about 10,000 feet, which is my cruising altitude. But it's sometimes useful to look at the 850 millibars as well, because sometimes the wave can just be low level. So, as I say, what you do is you go to the 2-kilometer, and if I just bring up the 2-kilometer, now I used last Saturday as an example because that was a wave day, and the point I'll make about if you want to get the 2-kilometer chart for the actual day, it doesn't actually come online till about 8 o'clock. So normally what I'm doing is I look at the 2 kilometers for the day. If I'm wanting to fly on the Saturday, I'll look at the forecast day night before to plan my flight. And as I say, I'd use the 700 millibar wave forecast, which I'll just bring up because here it was for last Saturday, and at 9 o'clock, as we can see, we've got wave here. Now Port Moat's just down here, and there's not much of an indication of wave here, and it wasn't very good round here. But I'm just using this as an exercise. It was the last wave day that we've had that was usable. And as we can see, we have indications of waves. And I'm going to show you satellite photographs and webcams of the day. So one of the things is that when we go to the 2-kilometer charts, what you can do is you can get the soundings for Scotland, go up to here, click on the pages here and select soundings. And as we've got one there at Perth, we've got one at Crane Larrock. That's I think Inverary or Lochgilt Head. That's Feshy Bridge, Aboyne, so on, and that's Lossy, I think it is. and I think that's Easterton. But they're very useful to have. And that was taken at 9 o'clock. And I will say that RASP 2-kilometer charts tend to be more optimistic. They are optimistic, in my opinion. That's at 12 o'clock. And as you can see, showing quite a bit of wave here. Not so much here, but still okay there. Okay, so that's the soundings. And that's taken from RASP. And it's free. Now, what you then do is you then go to the endpoint page, and it used to be in the old days that you could actually draw the task on it, but unfortunately you can't do that now, which is a bit of a shame because it was a really useful function. But what I've done is I've got SkySight up, and this is, as I say, this is taken at 12 o'clock, and I'll bring the SkySight one up now. Sorry, I put the task in there, my apologies. There's the task in. Now, that's a long way to go from Portmore, but on the right day, I've done it before. I've gone up to Inverary to start, which is quite a long way, but you just do it. So, as I was saying, that's looking at SkySight, and that is around that is at midday, and as you can see, SkySight is not showing half as much wave. But the thing is, as I said, RASP tends to be too optimistic on the 2-kilometer. It's about right on the 4. But SkySight, in my opinion, tends to be a wee bit pessimistic. Now, you look at that and you think, well, that's not producing a lot of wave. Well, it is in certain ways, because there's 30 miles, right? Now, still air, 30 miles is going to be about 4,000 feet, possibly a bit more. But if you say with the wind, it's going to be 20 miles, right? So there's 20 miles. There's a wave bar. There's wave. There's wave. There's wave. And so the routing that I would take is, you've got to remember there's going to be a bit of cloud. The routing I would take is something like that. As you can see here, which is one of the big problems, is that the Great Glen, what tends to happen is air tends to channel up the Great Glen, and you tend to end up with a big hole here. But as you can see, you can go up like that, and then across, and then up, right? And actually this area here, I have it, I've been told, is actually quite good. So that's the sort of routing that I would follow. But you can see SkySight, I find that's one of the reasons why I have SkySight. And you can put this obviously on your RUDI as well. As I say, this is for the 2-kilometer, 7,000 foot. Yeah, as you said, I just see a question there. Which RASP sport? I think 2-kilometer, because 2 and 4 kilometers. That's what I think is best. All right. Now, one of the sort of things is cloud, and this again is on the 11th of April, just last Saturday, and Top Meteo is very good for cloud, but what I use is the normalized surface sun, which is basically showing the amount of solar radiation that is hitting the surface. And as you can see, out in the east, you've got almost 100% radiation hitting the surface, whereas here in the lee of the Great Glen, we've got cloud and more out here. Typical phone effect. Now, again, this is at 12 o'clock. At 9 o'clock, there would have been more of it. And basically what happens is it creeps back as the day goes on, and then it comes back in as the day cools. Now, from the wave point of view, this is actually not a very good, actually a very good indication, because you can sometimes see the wave bars in the solar radiation and the surface sun. But what's actually showing here is, I think these are more like cloud streets because they're going downwind. So those tends to be cloud streets. But there is an indication here of potential wave, but it's not a particularly good thing. But primarily what I use it for is to get an indication of what amount of cloud I've got. Top Meteo is actually quite a bit more sophisticated, so I tend to use Top Meteo quite a bit for cloud cover. It's quite good if you use it. But essentially, you can get all the information that you need off of RASP. All right, so we'll move on from there. Now, this is the satellite photograph taken from Top Meteo at 9 o'clock. And what we've got is top cover, and that's high cloud. And you can see that actually is, that's high level wave, which coincides actually with what we were looking at with the RASP, surface solar heating. But as I've said before, Valhalla, look at it up here, coming off Stornoway and so on. It's waving. And if you look down here, it's waving as well. And you can see indications of there. As I say, a lot of cloud around Portmoat, which meant that we couldn't fly until about lunchtime. But if I bring up the webcam for a Boyne, there's the webcam for a Boyne at 9 o'clock. I took that at 9:21. Got the high level cloud, and there's the wave bars. So there's where this is where you start putting all these things together on the actual day, or you can have a look if you have time. If I go to 12 o'clock, what's happening is the day's warming up, and as we again coming back to surface heating, solar radiation, here we've still got the top cover, but I think the wave's still there, because if the day's warmed up, the amount of cloud is reducing. We've still got cloud out here, and the wave is still going, particularly up there. And if you look at it closely, you can see there are indications of wave down here. And if I look at the webcam for a Boyne, there we have it. Now, you'd say, unfortunately, it's not gliders, these little specks. It's spider shit on the camera, but you know, could have been gliders. But there we've got a blue sky, and if you look at that, you can say, well, is that coming off the ridge a few miles up near Ballater? But no, I think that's wave, because it's a crosswind. And the thing that confirms it to me is that we've got this cloud here, and that's the same. And so I think that is pretty much almost a blue wave bar. And if we go to the evening, where what we've got is more cloud coming in, we can still see, this is all high level stuff, we can still see the waves there, and we can see it here. And this is at 1645. And there it is, and it's come back. So it's waving all day, and unfortunately we couldn't do it. So before, I was talking last week about the right atmosphere, and this is a basic tepigram. What you've got is the temperature, and what you want is it being unstable in the lower levels. Then you've got an area of stability, and then it starts to become unstable, and the wind increasing with height. Okay, so that's, here we've got the dew point. Where the dew point touches, we get cloud, as we can see. And as you can see, the wind's increasing in strength, so we've got a jet stream trapping it, and it's nice warm air. So if we think of wave as a spring, if it's nice and warm, we get a nice bounce, and if a spring's cold, then we don't get such a bounce. And ideally, what you want is the start of the inversion to be at the mountains at about 3,000 to 3,500 feet. That's what the average mountain height it is in Scotland. So we discussed that last week. Now what I'm going to do is put on the tepigram for last Saturday, and what we can see is that we've got an inversion, and that inversion actually starts at 2,000 feet, and it's up to about 7,000 feet, and then it goes on. Right now, if we look at the winds down this side, we can see the wind's reducing with altitude up to about 10,000 feet, and then it starts increasing. And we got a jet stream, or 50, or almost a jet stream, in the higher altitudes at about 30,000 feet. So apart from the wind reducing a little bit, which will give you possibly forward breaking wave, and the inversion being slightly on the low side at about 2,000 feet rather than 3,000 feet, then that's not a bad tepigram. And you really don't have to go into all the, you know, cloud water analysis and all the rest of the shit, right? All you've got to look at is the temperature and the dew point and the wind. The rest of the stuff you can read up. And if you go back to my bookmarks, there's a thing called thermobites, which is very good for understanding the tepigram. Now, this is a tepigram for the 21st of June, because we're going to finish off on that. And on the 21st of June, as I say, I attempted 500 Ks, and the last one was only 485. But if we look at it, it's quite classic, right? So you've got the jet, got a jet stream, got the wind increasing with altitude. It's all in the same direction. And we've got the inversion starting on, in this case, a bit high, about 6,000 feet. You've got the inversion and so on. And it's quite a dry air mass. Now, this little line, this little checkered line here is a thing called CAPE, right, which is convective available potential energy, right? So it's showing it's not a bad thermal day. And you can see here that really what we're going to have is slightly increases here. So that's showing that you're going to get cloud at around 5,000, 4,000 to 5,000, 6,000 feet. So yeah, so the inversion's actually, just looking at the inversion's just about right. It's not bad at all. So that's not a bad tepigram. Now, if I look at the task, and I'd set a 500, this was it at 9 o'clock in the morning, right? And I flew a task distance of 1,554 kilometers. I actually did about 1650. Now, the thing is the available daylight on that day was the sun rose at 4:24, and you can take off half an hour before sunrise, and sunset was 22:05. So including the half an hour before and after sunset, I had 18 hours available, or almost 19 hours available, right? So what I did, I thought, I'm going to go up, I'm going to stay up all day. So I got airborne at 4:56, and my wife actually ran the wingtip, you know, which was very kind of her. I'm a lucky man. And so I started at got airborne, aero tow straight into the wave, and got airborne 4:56. Started the task at Comrie just about an hour later. Okay, now just looking at it, you can see we spoke about the instigators, and basically the waves extending way up north, up past Torridon, up near up in the northeast. It's hitting around Loch Tay. It's getting amplified. It's terrific. You can see here it's a bit weak, and then up around Edsall. This is the Grampians. Really got a nice wave bar there. It's nice straight along it. So task settings, a piece of piss basically. You just pick points at the end of wave bar. So another point about this is Portmoak's just here. As you can see, as people did on that day, they got into the wave bar actually over Portmoak. So you got the wave bar at Portmoak. I took a tow to about here. So there's 1, 2, 3 wave bars to get to Comrie. It's a total of 4 wave bars if you include the one over Portmoak. To get up to Loch Tay, it's 1, 2, 3, 4, 5, and that's a cracker. And there's obviously Loch Tay itself there. The air's coming down, and that's where it's really good. So again, this is looking at 12 o'clock, and as we can see, we've got a bit of a gap here, which we have to cross. And actually on that day, I almost came around this sort of time, I almost came very close to chucking it in, because I got caught in the gap, and basically I ended up coming down to Perth, and then I got myself sorted out and went back up. And then this was it at 1900, and as you can see, it's getting pretty weak, although it's still okay. And I got to about here, and it had all gone blue, and I was been up for about 14, 15 hours, and I thought, you risk management, I better start. I'm tired. You don't want to start messing things up. Take the easy option. Don't take high risk. So I chucked it in about 15 kilometers short of the turn point, because I thought, you know, it's just the risk is just getting too great. So the total flight time was 15 hours 12 minutes. I took off at I landed I finished the task at Pomri at 1952, and I landed 17 minutes later because you got a fantastic tailwind to get back to Port Moat. Now I'm just going to finish now on the photographs, because this is a picture of the wave at 12:58. So I'm routing. This is on my second 500, and I'm routing from Crane Larrock, which is west of Loch Tay, up to Edzell. And the problem with the day was that unfortunately the airway is in the way, which we'll talk about next week. And basically around the Edzell area, the airway drops to 8.5. Before that, it's up at 10.5. Now Edzell is actually to the left of this wave bar, and so what I was having to do was to fly, and because of airspace restrictions, I couldn't climb over the wave because the airway, and I didn't have a transponder at that time, so I couldn't climb to get over the wave. So I had to take a more circuitous route. So I had to take the second wave bar down, and this wave bar goes to Montrose. And what I did then was take a climb and then dive across to get into Edzell and then get back onto the wave bar. It's the only way I could do it. So as you can see, it's pretty cloudy, and as you can see, but don't be intimidated by this, because the wave bar, it looks as if it's all joined up together, but that's because we're at a relatively low level, about 8,000–9,000 feet. For the wave bars, there'll be a gap here all the way up. So that was taken at 12:58, and this is the next photograph is showing it at 15:58, and I'm on the first leg of the last 500, and it's basically the same area. And as you can see, this wave bar is going up to Montrose, and what I do is I take a climb and then dive, which is not ideal because it slows you down. On that day, I only did 115 kph for most of the tasks, but and then on the last leg, it was really getting blue, and I thought, just minimize your risk. You've done enough. Just come home. So that was about it. That if you look at the area, this is one of the great advantages of Port Moat. You know, Aboyne's right in the mountains, so you get basically a bit more wave up at Aboyne. But the advantage that we have is we're flying over a lot more landable areas. So that's basically what I want to talk about today. I think that's about it. So we'll just go to the questions now. So what I'll do is I'll answer your questions. So I'm just looking at these ones. If you want to jump upwind, do you want to get to a place where the wave is less strong and so sink is also weaker? Yeah, what you do, I'll describe that more when we're talking about tactical flying. What you do is, obviously, you're going to get a wave bar, and a wave bar, some bits of it are working more than others. But what you do is you fly to the end of the wave bar and then jump across, because at the end of the wave bar, the lift is usually weaker, and what you do is you then jump at that point. If you're in 15 knots of lift and you jump straight into wind, you're going to get 15 knots down. And so the best thing to do, the idea is not to jump. The idea is to hopefully just make your way up wave bars and try and keep jumps to a minimum, because jumps use height, and what you want to do is you want to fly along the wave bar, climbing enough just to jump to the next one. So I've answered that question. Yeah, okay, water ballast in freezing conditions. I discussed that last week. I used 25%. The important thing, my glider doesn't have a tail tank, and it's really important that you have antifreeze in your tail tank, because you've got no room for expansion in the tail tank, and you'll rupture your tail. So it's really important you put antifreeze in the tail. In the wings, I use 25%, and that will do me up to -20. So it looks like there was no end to the bar. So you could, yeah. I'm not really sure of that question. I don't really understand that. Right, we'll just see. I'll just get out of this if I may, and then I can and then I can read the questions actually on the thingy. Right. Let me go here. Okay, let's just go through the questions. Let me just put this on presentation, and let's just do that. And let's just go to the end of the presentation. Right. Okay, so let's just have a look at the questions. We go from the beginning. Right. Right, that's okay. Okay, let's just see any questions. If we go to, let me just go to a certain chart. Oh, I know what I was looking at. We looked at, let me just go back. What you want nice straight isobars. What we've got here, that's anticyclonic flow, which is ideal. And what we've got there is cyclonic flow, which is not so good. The wind is actually coming across the wave bars here, whereas in a high pressure, it's very slightly out. But yeah, you want straight isobars, makes the wind nice and straight, so you get nice straight wave. Okay, so I answered the RASP. I think the 4 kilometer and the 4 kilometer and the 2 kilometer are most useful, but the 2 kilometer tends to be a bit optimistic. Yeah, we've answered that question. We've answered that one. I've answered water ballast. Well, how on earth do I stay comfortable in those? Well, I'm well equipped, which we can have a brief discussion about. I've got my OZ suit, I've got my boots, I've got my electric heaters for my shoes, for my feet, warm gloves, plenty of water. And if solar heating, if the sun's shining, you stay quite warm if you've got an OZ suit. And the way I look at it is I'm quite comfortable. My glider's comfortable. You definitely want to be comfortable. But I think of it, it's just like sitting in the bath for 15 hours, only you don't get so crinkly. You know, so it's just like lying in a bath. You're not doing much and you've got a terrific view. So what's uncomfortable about that? And if you're warm, there's no problems. What do I do to remain functional for 15 hours? Well, I wee a lot, and I suppose it's the adrenaline keeps you going. How do I persuade my wife to run at 4:30? Well, it costs me a lot. All right, how are we doing? Any other questions? Well, basically, you're not going to go far in low performance gliders. A K6E has done a 500-kilometer flight in wave from Port Moat. I mean, the problem is I originally had a Lebel. My first, when I started gliding again, I had a Lebel. And the reason why I got rid of it was because I was running out of performance. The Lebel's great, but once you go above 70 knots, the polar really starts crapping out. And once you start getting up to 80, I did my 500 in the Lebel, or my first declared 500 in the Lebel, and we'll talk about that next week. But basically, the Lebel runs out of performance. So really, I mean, I've done my gold height in a K8, so you can get your diamond heights and all the rest of it. I'm not saying that you can't do cross countries in wave in low performance gliders, but if the wind starts getting above 30 knots, up to 30, 40 knots, you really start running into problems in wooden gliders because the polar's crap. I mean, it's as simple as that. I mean, I'm now starting to get to the end of the discus performance. I think that if I did everything right, because I keep making mistakes, I don't think if I do a task faster, when I'm talking, if I do a closed task faster than 160 kph, I'll be happy with that. But basically, now low performance gliders, anything less than 1 in 30, you're really running into problems. K6E, they're okay. Skylark 4, nah, it's not going to do it. You're not going to go far, you know, unless you've got a nice wave bar to fly along and the wind's less than 30 knots. Have I had any issues with the gel coat on my glider? Essentially, no, because I don't fly high. The thing about the gel coat is I've had my glider refinished, and I've had it refinished 4 years ago, and I've got no problems with it. It was done by Ian Evans down at Shire Newton, and I've had no problems with it. But having said that, I don't fly high. And the thing is that what you do is you don't come down quickly. You allow the glider to warm up. If you're at 25,000 feet and you're back on the ground in half an hour, well, that's a good way to crack gel, you know. And so the thing to do is to do everything nice and slowly, and so let the glider warm up before you come down. But as I say, I very rarely fly above 15,000 feet. Temperature's usually about -15 there. Flying at these speeds can do a lot of damage. Well, not really. I mean, the thing is if you look at your rough airspeed, I mean, your rough airspeed, well, you've got your maneuvering speed and so on. I mean, if you hit right fair, no, I don't think it's going to damage the glider at all. The thing is obviously if you put a big input at that point, then that's the way you damage the glider by overstressing it. But turbulence and so on, I mean, the glider's quite strong. I mean, when you look at ultimate load factors and all the rest of it. So as far as UK is concerned, I don't think there's any issues with gusts and so on. It's not an issue. It's not going to damage the glider. Or up to now, I flew when we're looking at that forward braking wave. I flew, that was as rough as I've ever experienced, and you're not actually pulling that much G. I mean, the thing you've got to worry about is control deflection. You just do not do things rapidly if you start going into turbulence. And most of the time when you're flying in wave, it's usually quite smooth. It's only when you get into rotor or forward braking wave that you start getting turbulent, that you start getting turbulence. Do I dump the water before? I have landed with the water frozen, and where it has got very cold and it froze. But my glider, I can land at max landing weight. I'm limited to 450 kilos. Because I've got an engine. The actual certified weight is 525. So I can take the engine out and put more water in, but that's not a good idea. But I have landed with the water. Antifreeze is expensive, so I tend to try and keep it because I don't want to waste it. And so what I do is my glider can land at 525 kilos, so I'll drain it and keep it for the next time because it's expensive stuff. All right, anything else? Yeah, I have had it freeze, but if you wait, it'll unfreeze. As I say, you can land. How are we doing for time? That's about 56 minutes. We've got interpreting Met. We've got a Met brief on Thursday, and I'll be giving my next briefing next Saturday. I think Jake and Finn were organised to do a talk on next Sunday. So I'll be doing what I'll be having a look at. What I'll be looking at next week is be looking at airways for a little bit, and we'll be looking at task planning. And the idea is, I mean, these talks are basically intended for people that for people that have got Silver Seas and are wanting to do cross countries in wave. So it's anybody for, you know, Silver Sea and above. So as I say, we'll look at task planning. We'll have a look at the airways and task planning for next week, and then the final one will actually be about flying the task, where I've got some nice videos that John Williams has kindly lent me. Who does my hair? My wife. My wife does my hair. Not only she hold my wingtip, she also well, she can't now because she's getting too old now. So you know, she's her arthritis is starting to get the better of her. So is that grounds for divorce? I don't know. When am I coming to Denby? I'm a Portmoat man. I'm a Scottish man. Okay. Okay, we're finished for that, and we'll see you next week at Saturday 9 o'clock. As I say, good Met brief by Phil on Thursday. So I'll say cheers for now.